Okay, Illustrative Math, Unit 2, or Algebra 2, Unit 2, Lesson 9 is called End Behavior, Part 2. All right, our goal today. I can identify end behavior of a polynomial function from its equation, and I can create equations for polynomial functions with specific end behavior. Warm up. Match each of the graphs to the polynomial equation it represents. For the graph without a matching equation, write down what must be true about the polynomial equation. Okay, so when you look here at this, they put the little box in the middle because your graph could do whatever in the middle. Like, I'll give you a little example here. Your graph here could, this could go up and then come down. We're only worried about the ends. Okay, so here and here, the end behavior. We don't care about the middle. So this one here, left side up, right side up. So if you look at the chart that I gave you from the last unit, when the left side goes up and the right side goes up as well, this is going to be an even degree and a positive lead coefficient. So problem is equation 1 and 2 aren't in standard form. Now you don't need to multiply the whole thing out. You could if you wanted to. I would, if you were going to multiply the whole thing out, I'd start with maybe, doing those two, maybe doing a box, and then taking the x into the result of that. But really, you could just take the highest power term in each factor. So if I did x times x and then times negative x, okay, because x is a higher degree than a constant of 3. And same thing here, negative x, this is to the first, is a higher power. If you just multiply the highest power in each factor, we'd get x times negative x. That give me negative x cubed would be the first term. So positive and even, or negative and even, that means both of them are going down for that one. So that's not A. If I look here, this one has an even power and a positive leading coefficient. So this one would be graph A. Okay, and that would be 2. So those go together. Maybe I'll use a color here to color code this. Okay. Let's see, this one. Oops, that was a cubed. I'm sorry. That was a mistake. This was negative x cubed. Sorry. There we go. So that means, well, let's go back up to this. Let's go to this. Let's go to B. B looks like it's not going up or down. It looks like it's horizontal line. It's a constant, okay? So a constant is just a number. So there's the one we don't have the equation for. So I'm going to put here y equals some number. My y looks like a G. Let me rewrite that. Y equals, and I got to pick a positive number because it's above the x-axis. So I'm just going to say y equals 5. How's that? All right, there's no numbers on the axes, so I don't know if it's up at 10 or 100 or whatever. But I know it's positive because it's above. So that would be for that one. So this one will be yellow right there. Okay, let's go to the third one. Left side up, right side down. So if you look at your chart, or if you have your chart memorized, that's going to be an odd degree and a negative lead coefficient. So that's just like number 1 right there. So that would be matching up number 1 because I looked at this right here. I didn't have to multiply it all out. And then the last one, if you look here, let's just not just highlight them because they're the last two. Left side down, right side up. That's a odd degree and a positive leading coefficient. And if I look here, this is not multiplied out. But oh wait, hold on. Wait, I might have been wrong here. Hold on. So, ooh, tricky. This is a constant here. Ooh, they got me here. So let's look at this. If I were to distribute that, this would be y equals 5x plus 15 and then minus 5x. So then these are like terms, so those cancel. So this thing here is going to be y equals 15. So that's a constant actually. So I'm actually wrong here. This one is actually a constant, although it's disguised. It doesn't look like a constant, but once you get it simplified, you see that it is, whoops, you see that it is in fact a constant. So that would not be my last equation here. So I need to write one to match up with that. So I just, as long as it has an odd degree and a positive leading coefficient, something like this, y equals 2x cubed plus x squared plus 2x minus 1. I don't know. But the highest power is 3, and the lead coefficient is positive. So that would be right there. So they actually almost tricked me on that one. Okay. And this one could vary as long as this is an odd degree and positive leading coefficient. All right, write an equation for a polynomial with the following properties. It has an even degree, has at least two terms, and as the inputs get larger and larger in the negative direction or positive directions, the outputs get larger and larger in the negative direction. So my experience, this wording here, I'm going to highlight it, is basically just talking about end behavior. So inputs are x. So as the inputs get larger and larger in the negative or positive direction. So that's just saying as x goes left and as x goes right. The outputs are y, inputs are x. The outputs get larger and larger in the negative direction. So you might have to read this a couple times, but it's saying as I go left and right, the outputs are getting larger and larger in the negative direction. So it's basically saying your end behavior is like that, okay? Which would mean it's an even degree and the lead coefficient is negative. So lead coefficient negative and an even degree. So we just need to have at least two terms. So I'll use y equals negative 2x squared plus 1. How's that? At least two terms. Write an equation for polynomial with the following properties. It has an odd degree. It has at least two terms. So let's read this end behavior thing. As the inputs get larger and larger in the negative direction, the outputs get larger and larger in the positive direction. So that's saying as x goes left, y goes up. Okay? Because think about this here. These are your axes here. These are your inputs, negative that way, positive that way. And same thing up here on the y-axis, positive is this way, negative is that way. So as the inputs get larger and larger in the negative direction, as I go left, the outputs get larger and larger in positive. So it's like your arrow is going that way. Okay? And then the next part, I'll highlight that in a different color, just keep it straight. And as the inputs get larger and larger in the positive direction, so that's going right, the outputs get larger and larger in the negative. So as the inputs get larger and larger in positive, I'm going right, outputs get larger and larger in the negative. So your end behavior is like that. So that's a degree is odd. If you look at your chart, lead coefficient would be negative. So as long as I have two terms, I'll go with four terms here. But as long as the highest power is odd and a negative leading coefficient, we are good. All right, so here's m and n. M is right here, negative x cubed minus 2x plus 8, and here's n, negative 20x squared plus 3x plus 8. Describe the end behavior of m and n. So m, odd, negative. So odd, negative would look like that. So I'm going to use their terminology because that's how the book is gonna do this. As the inputs get larger and larger in the negative direction, the outputs get larger and larger in the positive direction. Okay, and again, you can think of it like this. That's the left part of the graph, but you could think of it like this. Here's your X, here's your Y. Your Y are the outputs, and positives this way, negatives this way. The X are the inputs. And again, positive to the right, negative to the left. So as the inputs get larger and larger in the negative, the outputs get larger and larger in the positive. Then the right side, as the inputs get larger and larger in the positive direction, the outputs get larger and larger in the negative direction. Okay, so that'd be for M. So this, I'm going to erase this thing here, just so we got that for M. And let's take a look at N. N is even degree, negative leading coefficient. So even degree, negative leading coefficient. Degree is 2, leading coefficient negative 20. So as the inputs get larger and larger in the negative direction, the outputs get larger and larger in the negative direction as well. As the inputs get larger in the positive direction, you could combine both of those. You could say, as the inputs get larger and larger in the positive and negative direction, the outputs get larger and larger in the negative direction. I just wrote it twice. All right, for x is greater than 0, which function do you think has greater values? Be prepared to share your reasoning with the class. Well, for x greater than 0. So the right side, so that's basically saying the right side. So the right side goes down on both of these. If you look at these here, the right side. So when x is getting bigger and bigger, we're going down. So the question is, which one of these has greater values? So n has a lower power than m. So what would happen is this one's going to go down steeper because it's got a higher power. It's going to get much, much bigger, okay? So I think that M is going to be basically what I think is going to happen is the right side of M is going to go down like this, and the right side of N is going to go down a little bit less. So that would make me think greater is larger, like in terms of Y values. So N, if I look at any given point here, the value at N is always above M. All right, no matter where you're at. Like if I look at those red points, I look at these green points stacked right on top of each other. See how N is always greater? So I would say I think N is greater because the degree of M is higher. So N behavior will be more dramatic. I say dramatic, I mean steeper, I guess. All right, so we're going to play another game. This time I'm going to supply the equations. So basically, we're just going to, if we were in class, we would use our hand signals. So I'm going to draw some stick figures here. And we're going to basically do the end behavior game again. And I had to put my fourth one up here. All right, so even negative leading coefficient. So both are going down. Okay. Odd positive leading coefficient. So right side up, left side down. Even degree positive leading coefficient. Both up. Negative leading coefficient, odd degree. So left side up, right side down. All right, goal. I can identify end behavior of polynomial function from its equation. I can create equations for polynomial functions with specific end behavior. I feel like I didn't create any equation. Did I create it? Oh yeah, I did, I guess. I did create one equation right here. So we did. Okay. Last thing here, cooldown and behavior, even power, negative leading coefficient. So even degree, leading coefficient, negative. So that's left side down, right side down. So I'm going to write it the way that the book does, just to make sure that we're good at that. And I'm going to combine it into one. Instead of saying as the inputs get more and more larger and larger in the negative direction, I'm going to say inputs and output, or inputs get larger and larger in the negative and positive direction. Okay, so I combine that there. Okay. All right. Hope you enjoyed today's lesson. Thanks for watching.